This is the solutions to numbers 5 through 9 from homework 7.2. We're asked to verify the following identities. Remember, when verifying an identity, you work with one side and one side only and show step by step how you can transform one side into the other. So for number 5, I'm going to start working with the left-hand side. Because I see cosine squared beta and sine squared beta, I'm going to think about the Pythagorean identity that has cosine squared beta and sine squared beta in it, and that is cosine squared beta plus sine squared beta is equal to 1. Since I want to get just to sine squared beta, I'm going to solve the Pythagorean identity for cosine squared beta. So I can get cosine squared beta equals 1 minus sine squared beta, and that's going to allow me to substitute into my original equation for cosine squared beta. So I'm going to put 1 minus sine squared beta in for cosine squared beta. So that's actually my first step. So I'm going to have 1 minus sine squared beta, that is what cosine squared beta is, minus, let me get rid of this line here, minus sine squared beta, and this is going to become 1 minus 2 sine squared beta, and we have verified the identity. For number 7, we have tangent squared theta plus 4 equals secant squared theta plus 3. If we want to go between tangent squared and secant squared, we can use another Pythagorean identity, which is I tan and secant, so we know that 1 plus tangent squared theta is equal to secant squared theta. So in number 7, we're trying to go from tangent squared theta plus 4 on the left side to secant squared theta plus 3 on the right side. So if we isolate tangent squared theta in our Pythagorean identity, we'll get tangent squared theta is equal to secant squared theta minus 1. So when I'm verifying the identity, I'm going to substitute in secant squared theta minus 1 for tangent squared theta on the left-hand side. And then when we combine like terms, we get secant squared theta plus 3 is equal to secant squared theta plus 3. So we verified the identity. And the last one on this page, we've got sine squared alpha minus sine to the 4th alpha equals cosine squared alpha minus cosine to the 4th alpha. I'm going to work with the left-hand side, and I'm going to see if I can factor. So I'm going to take out the greatest common factor, which is sine squared alpha. When I do that, I'm left with 1 minus sine squared alpha. And when I see 1 minus sine squared alpha, I'm going to think about the Pythagorean identity again that we used in number 5, which would be sine squared alpha minus cosine squared alpha. Plus cosine squared alpha equals 1. And we're trying to go from sine squared to cosine squared. So 1 minus sine squared alpha, if I isolate this here, I can say cosine squared alpha is equal to 1 minus sine squared alpha. So here I've got 1 minus sine squared alpha, so I can substitute in cosine squared alpha. And sine squared alpha, if I isolate sine squared alpha here, I can get that's equal to 1 minus cosine squared alpha. So I'll make that substitution in for sine squared alpha is 1 minus cosine squared alpha. And now we can distribute the cosine squared alpha to both terms in the parentheses, and that leaves us with cosine squared alpha minus cosine to the 4th alpha, which is what we're intending to verify. And so we're done.